Now we've already seen this printf function, which I used to display a string, and I embedded some data into the string. So here I've got 3 pieces of data following the string, and I have 3 replacement points, format specifiers, and those format specifiers are replaced by the data when the program's run. Printf is a very useful way of displaying data, and although it looks a bit complicated, it's worth getting to know. So I'm going to try and simplify this. If you look at the example in 04_printf in step 2, you'll find a simpler example of its usage. So here I have a program that first of all uses printf simply to display the string hello world with a new line at the end. Printf is not the only function that's available to me for printing strings. I could also use puts. This does exactly the same thing. It prints a string, and in this case I embed the new line character at the end. But puts can only display quite simple strings like this. Printf has another trick. Printf can substitute values into the string. So the way to do that is you write printf and then a pair of parentheses, then the string that you want displayed. Then optionally in this string you can have format specifiers. They're preceded by the %. %d says this is a decimal or integer value that I'm expecting. %s says this is a string. Then after the main string I put a comma, and then the values that I want substituted. In a real-world program, these could be variables, these could be pieces of data whose value will change each time the program is run, but here I've just used very simple values for clarity. So the first one is an integer, 20, and that will replace this point, and the second one is a string, wall, and that will replace this point. So %d will be removed from the string and replaced with the integer 20. %s will be removed from the string and replaced with the string wall. You can see this when I run the program. And there it is. There are 20 bottles standing on the wall. Printf is such a useful function that it's worth getting familiar with its use, but also beware. There are dangers here. C is not going to save you from any accidental errors you introduce. When it substitutes the values that you've put after the main string, it relies upon the programmer to have made sure that the values here are of the same types and the same numbers of the format specifiers in the string. Here I've got D saying it's a decimal or integer type. What if I replace that with an S which says it's a string type? Well, let's try it. Build and run. Up pops terminal, and immediately there's an error, segmentation fault. Now, in fact, I'm running this on OS X on the Mac, and it's relatively forgiving. On Windows, the results are catastrophic. As you can see here, my program just bombs out. So this is not desirable. It doesn't matter what operating system you're running on and how the error is dealt with. To have the wrong type of data and the wrong type of format specifier is going to result in problems. So you must take great care that the specifiers, the format specifiers, and the data with which those specifiers will be substituted match in both type and number. If I were to put the wrong number, so I'm going to put an extra one here. So now I have the right type here and the right type here, but I have another format specifier here without a piece of data to match it. When I run this, again an error. On the Mac, the error is not particularly catastrophic. Again, on other operating systems, there is no certainty that that will be the case. Here I am running the same program on Windows. In both cases, the end results are undesirable, and that's because I have made an error in my code. So printf, while it's a very, very useful function to use, does require some self-discipline and care. You must check very carefully that the actual pieces of data in the list following the string are matched in type and number by the format specifiers in the string.